Okay, so my final presentation was on cryptography. Um, I've always kind of been interested in cryptography. I think it's kind of cool to like encode messages and send your friends things or whatever. Like I was all into that when I was young. So cryptography, like looking into the history of it, goes clear back to like 1900 BC, back in like Old Kingdom Egypt and hieroglyphs and stuff. And like, if you look back at all these ancient civilizations, there's evidence that they were encrypting some of the things that they were saying. But it didn't, it really blew up in like World War II. There's that movie about like Germany or whatever. I didn't look too deep into this, but I do know it goes back to like World War II. And that's kind of when everything blew up, and that's when like more people started working on this to make it into the system that we have today. So this is from A Christmas Story, where he has the little thing and he has to decrypt this, and it says, be sure to drink your Ovaltine. To be honest, I've never seen A Christmas Story, so that's kind of embarrassing. But anyways, so what I'm talking about today is encrypting with, or cryptology, that this Lester Hill came up with using matrices. So it's called the Hill cipher, and it was a polygraphic substitution cipher based on linear algebra. Now, to be honest, I didn't look too far into this machine right here. Like, I'm not exactly sure how it worked, but I do know that it was invented by Lester in 1929. And it was practical, but could only did about 3 symbols at once, which isn't that many, like when you're trying to send a big code to someone. But so there's this thing with modulus in here, and I think I kind of wrapped my mind around this a little bit more, but I did a little bit different because I'll just get to it once we get to it. So anyways, so encryption is the transformation of data into some unreadable form. So it's changing your data to number and then mixing up all those numbers, and that's what you send out to someone, and they'd look at it and be like, what the heck? Where decryption is taking the encryption that you did and putting it back into an intelligible form that is actually readable. Okay, so what this Lester Hill guy did is he used a matrix to encode a message, which I didn't even know this was possible before looking into this. Like, honestly, when I took linear algebra back whenever I took it, I didn't see the use of matrices. Like, I didn't realize how much matrices are really used in the whole world, and I don't even think I realize it now. Like, I still don't completely understand. But, so the receiver of the message decodes it using the inverse matrix. And the first matrix is called the encoding matrix. So the only way to decode the message is to know the encoding matrix. And the inverse is called the decoding matrix, which makes sense. So I just want to go through like how to encode a message, because I thought it was kind of cool, and like this math is definitely math that we can do. So let's say we wanted to encode the message, I love math. Well, here, let's just use A equals 1, B equals 2, C equals 3, and so on till Z equals 26. Now, wherever there's spaces, and researching this, a lot of people like won't even put the spaces in there. Some people use 27 for the space. I'm just going to use 0 for the spaces. So this message would become 9, because I is 9, and I can write on this. So I is 9, 0, L is 12, O is 15, and so on and so on. So you end up with 9, 0, 12, 15, 22, 5, 0, 13, 1, 20, and 8. Okay, just from changing that, just using the alphabet here, and like the place in the alphabet. So if I want to put this into a matrix, I love math, I'm just going to use a 2-row matrix. So it'd be 9, 0, 12, 15, 22, 5, and I'm just reading these as I go left to right. 0, 13, 1, 28, and then I'm just going to put a 0 right there since we have that empty space. Okay. And I'm going to use this as my encoding matrix. Now you can use anything as an encoding matrix as long as it has an inverse. Okay, as far as I understand, you can use anything for your encoding matrix, it just has to have an inverse. So here, first, I want to encode this to make it into something that is not readable. So let's just say that A equals the 3, 5, 1, 2 matrix, and B equals the 9, 12, 22, blah, blah, blah. I can multiply these two together. So A times B would be that, and I just used my calculator here. Like, I did not do all of this out by hand. That would be so stupid and silly of me to do. And I ended up with 27, 9, 111, 42, 91, 32, 65, 26, 103, 41, 24, and 8. Now here, so this would be the message that you could send to someone. You could send them that list of numbers right there. And they would have to try and get back to the other list of numbers that would go back into the letters. Okay, and this is where I got lost with the modulus stuff, but I think I understand it. I'm going to go through and like decode this, but then I'm going to go back to this in just a second. But so here, to decode this, we need to multiply by the inverse, which makes sense because if AB equals, so I just kind of ignored this middle part right here. So AB equals this. Okay, that's what I got right here. Well, I need to get back to this equation, or that matrix right there. And the only way to do that would be to multiply by A inverse to the left sides of both of these. Because if you multiply by A inverse there, A inverse times A is the identity. So that just cancels out and you're left with B equals A inverse times that matrix. And then I just let my calculator find the inverse because, like, why not? We have calculators. So 3152 inverse times that, and we end up right back where we started. And you could pull out your calculator and check this. I promise it works. Which then if we just plug, so like 9 equaled I, 0 equaled a space. So you end up with I love math, which is that. Okay, I want to try and explain this modulus stuff. So if we go back to this, so we're going back to here. And it's mod 26. We want to do this mod 26 so that I could send back a message that is letters versus a message that is numbers. Okay, so if I send this mod 26, I can go through and change all this, and I get 1, 9, 7, 16, 13, 6, 13, 26, 25, 15, 24, 8. Okay, and that wasn't too bad to do. But then here's where I kept getting confused. So, all right, not right there, sorry. So this, if I change it to numbers, that could be my code that I send back. Like, that would be the letters I send back that you could encode to be I love math. Okay? But it was finding the inverse that I was like, okay, how do you find an inverse mod 26? Like, and I still don't understand it. Like, I think maybe if I really dove deep into this, I would start to understand it. But I found this like nifty little calculator that would just do it for me. So here's the calculator. And I could just put in 3, 5, 1, 2. So if I go to the calculator and I put 3, 5, 1, 2, modulus 26, it calculates it for me. So this is the part that I was like, I don't know what the heck I'm doing, but this nifty calculator did it for me and it worked. So if anyone gets that, or like if you want to try and get it, that's something very interesting. But so now I can take this A inverse mod 26 and multiply it by this mod 26, so like what I started with mod 26, and I end at 191, 52, 350, 223, all these big numbers. But if I do those all to the mod 26, then I end up at the 9, 0, 12, 15, which is what I had right here. So, oh, you can't even see my cursor. Sorry, I'm like pointing at things with my cursor, but it's not popping up. That's annoying. Which is I love math. Okay. Kind of cool. I thought it was interesting. And then I wanted to see like, okay, well, will this work with like a big matrix? So I did a 5x5 matrix. That's my coding matrix. And then I made this code. And this is a very long code. And I did not do this mod 26 because I didn't. But, so here, if that's my code and I have the coding matrix as a 5x5 matrix, I checked that it had an inverse. So here, I can put this into a matrix. I just need to make sure it has 5 rows. So I have 5 rows here, 6 columns. To decode this, I just need to multiply by the inverse on the left side. And I just let my calculator do this because we have calculators, like why not let them do it, you know? And I ended up with this. So 9, 0, 23, 1, 14, 20. And notice all of those are under 26. Okay, which is like, this always works. I think the mod 26 thing will make it so that you can send back a code that is letters. But this, it always works with numbers if like you're cool with sending numbers, I guess. I don't know. But here, if we encode this, we end up with that, which is, I want to go back to real life because this sucks so freaking bad. But yeah, that's my presentation. I thought coding was kind of cool. I always like to find applications like this that I'm more interested in. And yeah, Donald Trump says bye and have a great time. Okay.